Hello, this is Scholar Strive doing some math. Today in geometry, we're going to prove theorems about perpendicular lines. So let's look at some vocabulary and some theorems and some other stuff. So here we go. The distance from a point not on a line to a line is always defined as perpendicular distance or the length of the perpendicular segment from the point to the line. But basically what they're saying is if we have so if we're trying to find a distance from a line to a point, we always measure the distance perpendicular to that line. So we always measure that distance. We don't measure it from the left side or the right side. That's just too long. The closest distance to that line is the perpendicular distance. Okay. So if two lines intersect to form a linear pair, okay, we have two lines. They intersect. And they form a linear pair of congruent angles. So here's 1 and 2. They say angle 1 is congruent to angle 2, and they form a linear pair. That means they're supplementary, which means angle 1 plus angle 2 equals 180. So since they're equal, that means each of these is 90 degrees. So that's why those are perpendicular. So if two lines are perpendicular, then they form 4 right angles. And that is true. If these are perpendicular, you got one right angle there, another one, and another one, and another one. If two sides of two adjacent acute angles, so adjacent means next to. So this angle here, that's angle 1 and angle 2, they're next to each other. And these are acute angles, so they're less than 90. So if the two sides of two adjacent acute angles are perpendicular, so that means this whole angle is perpendicular, then the angles are complementary. Yeah, that's true, because angle 1 plus angle 2 equals 9. They have to be complementary. Yeah, if their two sides are perpendicular, that means that whole thing's a right angle. And then two small angles put together have to equal that 90 degrees, so therefore they are complementary. Perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it must be perpendicular to the other line. Okay, so here's our two lines. And then our red transversal. And what they're saying, if the two black lines are parallel, and if the transversal is perpendicular to one of them, then it must also be perpendicular to the other one. Okay, lines perpendicular to a transversal. So if in a plane, if two lines are perpendicular to the same line, then the two lines must be parallel. So this is kind of working backwards. If you have, let's go make the red line here. So they're starting off with the red transversal, and it's saying that it's perpendicular to both of these. So if it's perpendicular to both these lines, then it's parallel. So just working backwards. So if two lines are parallel and it's one transversal is perpendicular to one line, then it's also perpendicular to the other line. And then backwards, if you have a transversal that's perpendicular to two lines, and those two lines are parallel. So in the diagram, angle 1 is congruent to angle 2. What can you conclude about lines A and B? So we know that measure of angle 1 is equal to measure of angle 2. And we know that we can assume that angle 1 and angle 2 are a linear pair, because they are next to each other and they add up to a straight line. And a straight line is 180. So they are supplementary. That means each angle is 90. Therefore, A is perpendicular to B. Where did this come from? And why can't I get rid of it? Nope. Close, please. How do I close? Pausing. Alright, I got rid of that window. Here we go. Okay, proof time. Angle 1 is congruent to angle 2. Prove that angle 3 and angle 4 are complementary. Okay? So we're going to use what we basically just did in example 1 for the most part. So, statement. I'm not going to have enough space. Let's see if I can give myself more space. So statement, reason. Alright, 1. Always start out with what you're given. So angle 1 is congruent to angle 2. Given. 2. The measure of angle 1 is equal to the measure of angle 2. And that is through the definition of congruent angles. If two angles are congruent, then their measures are the same. So 3. We now said angle 1 is supplementary to angle 2. That's because if two angles are a linear pair, then they are supplementary. So if two angles are a linear pair, then they're supplementary. And then number 4, we can say that QP, the line, is perpendicular to the line PS. And that comes from if two lines form a linear pair of congruent angles, then the lines are perpendicular. And now let's see if I can bring back that window. There we go. So number 5, angle QPS is a right angle. And that's because if lines are perpendicular, then they form right angles. Six, angle QPS is equal to 90 degrees. Definition of right angle. Number 7 now. Angle 3 plus angle 4 is equal to angle QPS. And that's the angle addition postulate. Angle addition postulate. That just says we can add 2 small angles and make a big angle. And then lastly, we have now shown that angle 3 is complementary to angle 4. Because if 2 angles add up to 90, or let's just say definition of complementary angles. If 2 angles add up to 90, then they're complementary. Definition, complementary angles. Okay, so let's go back. So we all started off with angle 1 is congruent to angle 2. And they showed it, so on this picture they're right next to each other. So we know we're probably going to use some sort of fact about perpendicular lines. So without even looking at what we're trying to prove, I just went through exhaustively what this all meant. So angle 1 is congruent to angle 2. That means their measures are the same. If their measures are the same, that means they're also supplementary because they add up to 180. And they're a linear pair. So since they add up to 180 and they're the same, that means they're both 90 degrees. That means QP has to be perpendicular to PS. And since those are perpendicular, that means we have 4 right angles. Now at this point, instead of saying QPS is a right angle, SPV is a right angle, angle 1 is a right angle, angle 2 is a right angle, I then, focused on what we're actually trying to prove here. You could put all that down, and you won't get it wrong for it, but we're going in a specific direction. Angle 3 and angle 4 are complementary. So to prove something, our 2 angles are complementary, we need to show that they add up to 90 degrees. So we need to first establish what is angle 3 and angle 4. Well, angle 3 plus angle 4 is angle QPS. And now that we know that angle 3 plus angle 4 is QPS, we need to show that angle QPS is indeed 90. So that's what we did before there in 5 and 6. QPS is a right angle because of perpendicular lines. And then because they're perpendicular, because it's a right angle, it's 90 degrees. So now that we have established that QPS is 90 degrees, we can now say that angle 3 and angle 4 are complementary. It's a long process, but it logically flows. And once again, you should not be masters of proof, but as you keep watching these and looking through these proofs, hopefully you're starting to see it a little. Your brains will hopefully start growing some, I forgot the term, but start making new branch pathways, and hopefully this starts to get a little bit easier as you see it more and more. All right, was that it? Uh-oh. How do I close this again? Oh, there we go. Nope. Oh no. Not really long. Okay, here we go. Let's keep going. So use the diagram for example 2 to prove that angle QPS and angle 1 are right angles. So angle 1 is congruent to angle 2. Oh, where's my pen? Given. QP is perpendicular to PS if 2 lines form a linear pair. Of congruent angles, then the lines are perpendicular. Angle QPS and angle 1 are right angles. If 2 lines are perpendicular, then they form right angles. And they form 4 right angles. Checkpoint 2. If C is perpendicular to D, what can you conclude about the sum of measures 3 and 4? They add up to 180. Because all of those are 90 degrees, so they add up to 180. Decide which lines, if any, are parallel in the diagram. So we can say R is parallel to S. So if we're looking at R and S, and then we look at the transversal X, so ignore all the other lines except for the 2 black ones in the red. We notice that those 2 lines are perpendicular to both, or that X is perpendicular to both R and S. Therefore, R and S are parallel. Okay. Now let's look at X and Z. So X and Z. So we're just going to be looking at the 2 green lines and the red transversal. So S is perpendicular to both X and Z. So that means those 2 lines are parallel. So X is parallel to Z. And then let's look at X and Y. And basically it's the same reason, but let's go use colors to make sure what we know we're talking about. So X is parallel to Y because, so X, Y, and then red here. So as you notice, this red line is perpendicular to both the 2 green lines. Therefore, those lines are parallel. And I don't think there's any more. All right. Let's move on. Well, okay, well, there's one more. X is parallel to Y, which is parallel to Z. So since z is parallel to x and x is parallel to y, that we can say z is parallel to x and y. Okay. So those three are parallel to each other. Checkpoint 3. Is C parallel to D? So what do we got? So C parallel to D. Oops. And then if we take a look at this red transversal, we notice that those are perpendicular. So yes. And then is B parallel to D, or perpendicular to D? So this one's also yes. And this is how the reasoning goes for this one. So A is parallel to B because transversal C. So let me show you in colors. So A is parallel to B because of transversal C is perpendicular to both A and B. So A and B are parallel. C is parallel to D because of A. So we're going to use that explanation there. Now finally, we can say if A is perpendicular to D and A is both parallel to B, then B is perpendicular to D. All right. What do we have here? Find the distance between the train tracks. Okay. So we're going to first use the slope formula to find the slope of QR. So from here to here. So 55 minus 34 over 91 minus 71. So again, that's y2 minus y1 over x2 minus x1. And we're going to get 21 over 20. Now we're going to use that to find the slope of PQ. Or now we're going to use the slope formula again. Find the slope of PQ. PQ 74 minus 34 over 29 minus 71. And that'll give me 40 over negative 42, which reduces to 20 over 21. These are perpendicular, yes. Because the slopes are opposite reciprocals. Now we know that those are perpendicular. We can find the distance formula from P to Q. Okay. So we punch this in here. 71 minus 29 squared plus 34 minus 74 squared. 42 squared plus negative 40 squared. 1764 plus 1600. So we take the square root of that and get, wow, that's nice. That can't be a calculator. Square root of 3064. Oh wow. Yeah, it comes out to 58. Uh, 58 units. So since they didn't give us any measurements. And that is all for today.